Thank you for being here. My name is Ganesh. I lead the business for IoT within Hitachi Digital Services. Thanks for taking this time to be here, to be part of this session. I'm going to share our experience about how we bring in transformation in the digital operations from a lights out factory situation. Now, obviously, when I talk about lights out, one of the key aspects is the overall asset performance. And I'm going to showcase in terms of how we as Hitachi Digital Services have built this platform in partnership with AWS and how this has helped our customers realize business value in this journey. So to begin with, I want to introduce first Hitachi. I'm sure this name is very familiar to all of you, but one of the core aspects of today's conversation, especially in the context of Industry 4.0, is while we have a legacy of about 100 years in existence, Hitachi is a OT first company. We are an operational technology company. We make products, we make systems that touches humans every single day, whether it is the energy that we produce through our energy systems, whether it is the trains and locomotives that Hitachi builds, or it is the elevators and escalators and the appliances that touches every day in a life of every human beings, right? So we as a business are primarily focusing towards social innovation, how technology can bring in that social innovation, and how the world of operational technology and the information technology comes together, because that's the most important pressing challenges that everybody has is, I have this whole IT data, how do I realize the value of OT and IT together? That is what we excel as an OT first company. So having said that, I wanted to talk about our AWS partnership. Obviously, we are a manufacturer, we are a technology provider, we are a consulting and a system integrator. So given the diverse business of Hitachi and our solutions in the digital arena, one of the key things is a partnership with an hyperscaler like AWS. What I'm going to talk about here, a lot of that is already practiced within our ecosystem, with our own operations, with our own assets. So today, if consumers are getting uninterrupted power supply, so how do we keep our assets running 24/7 with zero downtime? So all of that requires a strong technology backing, and that's where Hitachi and AWS are coming together in building some of the AWS services and bringing all of the OT technology powered by the AWS services into the customer. So that's backed by a strong capability, the center of excellence that we have built within Hitachi. Now, little bit of how we look at digital transformation, how we look at IT and OT together, right? Obviously, you've been hearing the word of data, cloud, and hardware and sensors, right? So for us, it's an intersection of cloud, data, and IoT. That's how we look at the world of IT-OT integration. This requires a strong focus towards advisory, helping customers discover where their gaps are and how do we walk them through the journey, handhold them through the journey of transformation with all of these three building blocks. Because one is connectivity, collecting information from your sensors, from your hardware. Obviously, how do you process the data? How do you handle the big data situation from a cloud point of view? How do you bring in all of the technology from a more of autonomous processing, AI, machine learning models, Gen AI? So this is what we do. And how this can power your social systems, transportation systems, energy systems. That's really how these three technology pillars are coming together, powered by the Gen AI solutions that we do. Having said that, if I look at an enterprise world, obviously what are we seeing as opportunities for us? In the emerging world, there are multiple aspects from a smart mobility point of view, sustainability point of view, and a lot of new markets are evolving. And obviously, there is also change that is driven by the technology trends there. So these are some of the factors that are influencing our thinking. These are the factors that are driving the need for a better OT-IT integration possibilities. This is one aspect of the puzzle. The second part is what's happening in the manufacturing space. What are the disruptions that we are seeing? Obviously, the customer demands have become a lot more dynamic. The needs are more dynamic, there is a more of flexible manufacturing. Competition is coming from different dimensions. If you look at the traditional automotive world, the EV world changed the entire competition. It's not anymore the hardware, it is the software that makes the difference. So across the world of mobility and the EV world, there are so many disruptions that are bringing into the market. Sustainability is driving more need for innovation and causing disruptions in terms of what kind of green energy that you can actually use in your manufacturing aspect. Then obviously the whole connected ecosystem, the supply chain, the nimbleness in supply chain, the disruptions, the dynamic changes. There are so many geopolitical situations that are driving the overall manufacturing process. Inflation, fuel prices. So a lot of this is actually impacting the manufacturing customer. So this is the second dimension that I wanted to talk about in terms of how we build a very nimble, agile, resilient manufacturing operations. The third aspect is the technology innovations, the art of possibilities that can help you in terms of addressing the need, whether it is wearables, whether it is 5G connectivity, whether it is AI, machine learning models, whether there is more GenAI solutions, connectivity. So all of these technology building blocks or these emerging technologies are fueling innovation and helping us in terms of create new differentiated products to our customers, powered by a stronger ecosystem, the digital ecosystem that we bring in, whether it is the sensors, whether it is the ability to process large volume of data, whether it is the deeper insights that you are able to collect through the social ecosystem possible. So these three elements of the emerging market trends, the disruptions in the manufacturing space, and the new technology solutions that we have are all paving way for building a resilient asset, resilient manufacturing ecosystem. And this is the foundation for us to talk about how we can enable a lights out manufacturing solution for our customers. Now, obviously I started with saying that Hitachi is a pedigree of manufacturing. We operate actually close to about 800 factories of our own factories. We build large systems that are powering the entire economy. Now that requires a strong innovative culture. So if you look at our manufacturing landscape, the investments that we have made within the Lumada ecosystem, it's all about the value chain of the ecosystem, right from materials, the machines, the assets, the human, and how do we bring technology into it? How do we bring sensorization into it? How do we process large volume of data? How do you build flexible systems? How do you build autonomous systems in the manufacturing parts? And how do you bring in the whole rigor of the closed loop ecosystem of continuously innovating, continuously evolving? And one of the things that we are really proud of in terms of embedding the Japanese culture of precision for quality, precision for perfection, all into the process of the platforms that we have built. And that is really what is in the innovation lab that we have today. So bringing in technology, bringing in AI solutions, bringing in robotics are some of the key aspects of how we drive manufacturing innovation possible. Today, we are seeing challenges. The skill set level of people that we are getting is going to be a challenge. Availability of talent is a challenge. There is a lot of variability in our enterprise operations. So that is the reason why you need a strong manufacturing ecosystem and a platform that is going to really help us. Now, obviously, with the theme of the event, the whole journey is how do we help our customers in the Industry 4.0 roadmap? How do we handle them? How do we take them through this journey? And one of the key aspects is, obviously, the uniqueness for us as Hitachi is it's not just about technology solutions. It's also about the subject matter expertise that we bring in from 100 years of legacy when you operate a machine, when you operate an asset. So we have that expertise that's coming along to solve our customers' problems. Today, when we engage with our customers, it is just not the technology solution, it is the hands-on experience that we have solved in addressing large complex systems that are building this solution. And that's where this roadmap comes in, is in terms of how do you establish a stronger aspect of visualization, connectivity? How do you drive in more maturity in terms of your data rigor in the process? That requires a stronger platform to do. and primarily walking the customer through the journey of various stages of maturity, whether it's sustainability, whether it is supply chain, production, and all of this needs to be embedded into a platform. And that's the most important point here is the reason why I'm laying out is you need to have a roadmap and you need the technology solutions to back you in building this roadmap, driving a stronger data culture, driving an integration of various processes. Companies struggle in silos of digital because everybody talks about digital transformation, but there are a lot of digital silos within the organization. Materials, supply chain, R&D, manufacturing, they do digital projects, but at the end of the day, one digital transformation does not connect to the other digital transformation. One system does not talk to another system. So in eventuality, you are not able to drive the digital fabric across the enterprise. And that's an area where we need to emphasize, and that is what we have done within the asset reliability framework that I'm going to talk about. Let me play a small video in terms of what this platform is. So this is part of our initiative for industry cloud for manufacturing, industry cloud for energy, and industry cloud for mobility. So as I started my session, when we talk about lights out factory, one of the critical operations is asset reliability. An asset could be a machine, a forklift, a motor, a drive, a substation, a train. It could be any form of an asset, but how do you help the asset owner in enabling connectivity across all the various elements to it? There are thousands and millions of sensors, so collection of data, processing in real time, and helping the end user from a visualization point of view, building strong predictive models, first principles, physics of failure, database predictive analytics, all of that in a platform that is user friendly and can consume the data in a very rich visualization point of view. So this is what we have built from an industry cloud point of view jointly with AWS. And this is a framework. I'm talking about customer success out of it, but let me give you the video. So let me explain in terms of how this platform works. So obviously, here is an example where we are connecting multiple factories, and within the factories, there are various assets, machinery, and primarily our focus is towards measuring the overall equipment effectiveness. The overall equipment effectiveness is measured by 3 factors: availability of the machine, performance of the machine, and the quality of the process. So these are the 3 variables. Now, this is for an enterprise having factories and operations across the globe, globally across different sites. So this is particularly collecting data from different machines in a typical factory layout like this. You have different assets, different operating procedures, operating sequence, and for each of the machine, each of the process, we are able to connect and analyze the data by the various job orders, by the production quantity, and looking at all of the performance. So if you look at it, this particular process is making a large transformer, and this transformer has actually 4 different stages of a machine. So we are able to connect, and these machines could be of different life cycles. So different protocols, different connectivity protocols, different sensors. So how do we connect with machines of different life cycles, different data protocols, collecting the data, able to predict what is the overall equipment effectiveness, and then you are able to see in terms of all the prescriptive, descriptive information about that particular asset, what is the alert, what are the failure modes, what is the probability of the failure, what is the mean time to repair. So you get very insightful deep dive of every single workflow, every single process within the value stream. And then it is for the operator, it is for the maintenance technician, it is for the end users to actually deep dive in terms of what is the risk in the machine, what are the critical parameters, what is this failure triggering about, and driving certain follow-up subsequent actions from an SAP work order or from a maintenance planning or from a predictability point of view, driving certain business actions. So in a way, this helps the shop floor manager, the product manager in terms of his predictability. And we are able to model a complex scenario of high volume big data with a time series data, able to predict on various scenarios, whether it's a temperature profile, whether it's a vibration, or any other sensors that are coming from this particular machine. And then it's a system of systems. So you are actually able to model every single system in the entire value chain. That's one factory. Then there are multiple factories. So you're able to benchmark across sites, across the enterprise, and then have a better predictability of it. It also helps you to plan a dynamic supply chain, because if I know that this particular line is going to be shut down because of this failure, I can balance my production accordingly from a global network of supply chain. So that's how this platform is helping. So it has pre-built models, we have the asset data models, and all the failure modes which are able to help diagnose the failures. It is also helping me to give a risk scorecard in terms of what are the various failure modes, what are the risk patterns, what root causes that are actually helping us. So this is how this entire asset model is built. Now this could be a factory machine, this could be a substation, this could be a car, all different subsystems. So all of these failure modes are connected. And also it is much more flexible for the operators to customize it, to create the visualizations, create more insights, and thereby you are able to program and optimize your entire operating cost. Because obviously you don't need to be more of building your maintenance strategy. This is driven by more prescriptive failures. So obviously you are driving your entire maintenance around reliability centered maintenance, your cost of maintenance, your overall plant effectiveness, efficiency is driven by that. Again, it's a scalable platform. It has a lot of library data models built for different assets classes, different asset hierarchies, and very flexible. Technically, for a customer, it would be probably 4 weeks by which you can actually build the entire asset library, asset model, and then get this rolling out into a factory or into an asset category. That's the value of it, and the user interface, the visualization is a lot more flexible. The second part is the ML models. So it's a pump, it's a conveyor, so you have all the pre-built ML models which are actually helping us to predict the overall failure mode. So that's a quick view. Now, how we are looking out is basically, if you look at, we have already digitized a lot of the processes. We have more or less focusing towards building stronger machine learning models, stronger AI models. The second part, or the next part, is in terms of enabling an end-to-end closed loop ecosystem which is more autonomous driven. Systems that can fix themselves based on failures. So what we are right now focusing primarily is using this data, using these insights, how can we pivot towards more self-healing methods, which are primarily helping in terms of identifying the right failure modes, changing the geometry based on temperature parameters, based on certain geometrical characteristics, and drive more autonomous recovery of the systems. So that's where we are today. Now, to summarize, what we bring from overall as industry cloud for manufacturing is a digital thread across the enterprise. A lot of times I said customers struggle with the digital silos. So the left mode part is how do you bring in the digital thread or the digital fabric from your PLM systems, your ALM systems, and then using that digital thread across your manufacturing process, because you have a traceability, you have a strong view of the digital passport of how a product is manufactured. Every aspect of it is recorded, tracked, and you have a traceability available part of it. In that process, obviously today with sustainability, we need to have a strong visualization of what is my scope 1, scope 2, scope 3 energy footprint, carbon footprint. So the sustainability aspect, the energy management is also driven by this platform, and primarily today the world of quality is all driven by computer vision, all of your ML models. So using cameras, using sensors, how do you drive video intelligence? Because obviously you want to take away the dependency from the operators through more of computer vision based models. So collectively, if you look at HARC is Hitachi Application Reliability Center. So this is driving the operational technology with these 4 layers of ALM, PLM, supporting the smart manufacturing powered by a strong sustainability focus, looking at carbon footprint reduction, and primarily bringing in more of computer vision, video intelligence, driving the overall manufacturing process or maintenance process. So this is how we brought all of those platforms together driving value, driving a closed loop thinking, and driving more of autonomous way of operations. Now, obviously, as a practitioner, as an advisor to a lot of customers, there are several of our customers who have benefited significantly from what I showed, right? A large automotive manufacturer who is now transitioning from traditional IC engines to battery plants. We help them put together the future of the factory of the future manufacturing landscape, clearly building data models for how a battery manufacturing plant would be. What are the actual connectivity to different machines, building in a strong machine reliability focus, helping them define the future of manufacturing platforms, everything cloud-based. Because if you take 40 factories, each factory has different hardware, different softwares. You can't be changing everything over years. So those layers remain what they are, but building a product agnostic data engineering, data lake, and how do you bring everything into visualization. So that has helped us to save significant amount of operational OPEX and CAPEX initiatives in this customer. And likewise, whether it's a paper industry, whether it is a tire industry, or across different products, whether it is steel manufacturing, aluminum manufacturing processes, focusing towards energy reduction, focusing towards carbon footprint reduction, driving customers to build more flexible manufacturing. These are all the systems that we have been able to help customers with. The other important aspect is how this helps in the digital twin journey. Because obviously a stronger data culture, stronger manufacturing platform. So we've been able to build a holistic digital twin model for a tire manufacturing process. For example, in a tire manufacturing process, the rubber compounds actually have a significant variability of sourcing raw materials. Now, obviously, with that wide range of variability, if you set your machine parameters, it's going to affect your overall product quality. So we built a digital twin model where you are actually considering the noise variables that are coming from the raw material and define critical set points in your machines so that in spite of the variability in raw materials, you are still able to deliver a consistent product quality to the customers. Similarly, in the mining industry, how do you extract a higher grade of coal through the mining process? A digital twin was built in terms of entire value chain of the coal mining process. Similarly, in cables, in terms of vulcanization process, there are quite a lot of variables we could do. Similarly, in food processing, how do you build digital twin in food processing to increase, to reduce contamination, to increase yields, at the same time making sure that product consistency across several variables in a process plant. So these are several such examples in terms of how we have been able to drive, bringing in a strong platform-centric approach, a strong data organization, and driving a digital twin through the industry cloud platform that I demonstrated. And this is what we call as HARC for OT, which is basically Hitachi Application Reliability Center for Operational Technology. I will stop here, and any questions that I can take right now. Thank you so much for your participation.